So here's our task. The question says, a conical cup is 4 centimeters across and 6 centimeters deep. Water leaks out the bottom at a rate of 2 centimeters cubed per second. How fast is the water level dropping when the height of the water is 3 centimeters? So basically, we are trying to find at which rate the water level drops inside this cup. Given the volume of the water in this funnel is decreasing at a rate of 2 centimeters per second, and since the water is decreasing, that number turns negative. By reading this problem, we know that the height of the cup is 6 centimeters and has a diameter of 4 centimeters. We are trying to solve for the rate of change of when the water is at 3 centimeters. So how do we find the rate at which the water level changes if we are given the change in the volume? First, we must find the equation that relates to volume. In our case, our equation will be V equals 1/3 pi r squared times h. This will be the equation that will help us find the rates. Since we want to solve this equation with respect to h, we don't want the r there because we want to relate the volume to h. Therefore, we have to find a way to replace r with h. Once again, by looking at the problem, we are given the diameter of the top of the cone, the diameter being 4 centimeters, which can then turn into the radius of 2 centimeters. We are also given the height, which is 6 centimeters. These two values show us the ratio of r to h, that being 2/6 or 1/3. Now we can say that r is equal to 1/3h. This ratio has also allowed us to substitute r inside of the equation. Now we want to make this pretty and simplify it. Now we have volume is equal to 1/27 pi h cubed. Now we can take the derivative of both sides with respect to d/dt. By looking at our new equation, we now have dv/dt on the left, and when we use the power rule on h cubed, we get 3h squared. So that gives us pi/27 times 3h squared. And we can't forget to put dh/dt when we take the derivative of h. Further simplifying, we are now left with dv/dt is equal to pi/9h squared, dh/dt. This leaves us with the relationship between dv/dt and dh/dt. And since we are looking for dh/dt and are given dv/dt and h, we can now put in our values. Therefore, giving us -2 is equal to pi/9 times 9, dh/dt, resulting in our answer, which is -2/pi centimeters per second is equal to dh/dt.